Topic of our project is implementation of a digital oscilloscope based on an FPGA. The people involved in this are Rajamuri Srivardhan Reddy, Soham Prashant Erande, Vaishnav Prakash, and Vivek Mudi Reddy. Hello, so our project is building a digital oscilloscope using an FPGA. We have used a 640 cross 480 VGA sync generator, and we have assumed the input 100 megahertz clock from the FPGA for this project. So we essentially have two important modules in this. The first one is the VGA and the second one is the function generator. The VGA module is just the module for the screen which operates on a frequency of 25 megahertz, for which we have a frequency divider. We have a few parameters: H display, H back, H front, H sync. Similarly for the vertical parameters, these are the horizontal constants, these are the vertical constants. These essentially show the amount of duration for which the signal is active versus this amount of durations, which is 48 plus 16 plus 98, where the signal comes to a rest in order to avoid glitches and overheating. There are other parameters which also ensure that we have the correct timestamps for the sync signals starting and ending for both horizontal and vertical, and maximum values of these signals. So essentially we have a width of 800 pixels, which are just clock signals for the horizontal display as shown, which is the sum of all these. Similarly for the vertical one. So this is essentially the signal which helps us draw the horizontal signals. This is the one for vertical signals, are essentially counters. So this is just a counter to tell us whether we are in the current operating region or we are in a region where we need to pause. Similarly here as well. So there is a display on, which is just to tell us whether we are in the safe area where we can operate. And this is a LED just to tell whether we are our FPGA. We call the function generator here, which what it does I'll explain ahead. So this is the function generator. We have a few parameters which denote the vertical center of the screen, the base amplitude, the base period, and the line thickness. The base period is essentially what, for how much duration a black line or a combination of red, green, and blue line should be drawn with respect to the time period. So essentially, these can be scaled up or scaled down, the amplitude and the frequency, based on what amplitude and frequency we want, which is just zooming in and zooming out from the uh, e- digital oscilloscope. So these are a few signals that we can generate based on what wave we want. So this is a square wave. If it is given, it will be correctly displayed on the VGA. What it essentially does is it checks the local current position. If it is lesser than the half of the frequency, it will draw a horizontal line, which has a width of 2b, since these parameters are checked here. If it is greater after that point, a same vertical line is drawn. It is just below rather than above. So we get the positive and negative horizontal lines. Similarly, we get the vertical lines with the same width 2b. And like we have the square wave, we have a sawtooth wave, we have a triangular wave, we also have a horizontal line. We can also generate sine waves. It's just a combination of how we can code these, and there will be a multiplexer which essentially selects which one of these signals we want, and based on that we have these RGB pixels. Whenever the pixel on is on, which is this particular signal, there will always be one, which a combination of which gives us a white colored signal. Otherwise, it is zero. That's essentially what our.
This is the test bench that we've written for simulating the digital oscilloscope. Its inputs are reset, which resets VGA controller and wave generator, clock, time divisor, which controls time scaling, amplitude, and wave type, which selects the waveform depending upon its value. The output signals are the RGB values, which are the pixel color values, the H sync and V sync, which are VGA synchronization, and LED and debug, which are internal signals for confirmation during simulation. While testing, we first initialize the value of reset and clock to 0 and that of wave type to 00. After waiting for a short time, the reset will be set to 1, which means it is deactivated. Then it will display the square wave. Then when the value of wave type changes to 01, it will display the sawtooth. After when the wave type value changes to 10, it will display triangular wave, and when the value of wave type changes to 11, it will display a horizontal line.
Form that we get from our code and test bench. So basically what this shows is the time divisor and the amplitude, whatever maximum amplitude we want. The wave type specifies which wave is being generated. Whenever the RGB values are F, we can see that they are F at the same time. All of them being F is that it means that something is being written. All of being them being 0 is that means something nothing is being written. The H sync V sync values are 1 since these are active low signals. It ensures that we are on the display page itself. The LED one represents that it is printing what should be printed correctly. So if I had to zoom out a bit, you can see that there are many such instances where these F values are appearing.
So we have dumped the bitstream to FPGA. We can see that these two switches are to control the amplitude, these two switches are to control the frequency, and these two switches are to control the waveform type. So here initially 00 is square wave. So if we control the amplitude, this is a 01, this is 10, and this is a 11. Now let's control the frequency. This is 01, this is 10, and this is 11. So next we'll go to 01, which is sawtooth. This is the amplitude 01, 10, and 11. And now frequency 01, 10, and 11. Now 10 is triangular wave, 01 amplitude, 10 amplitude, and 11 amplitude. Now frequency 01, 10, and 11. Now we have sine wave for 11. This is the amplitude 01, 10, and 11. Now we have frequency 01, 10, and 11. These are the four waveform types which are displayed in a VGA monitor. Thank you.